Couldn't be there in class due to me getting COVID, so that's fun. It's for me. It's been a bad cold, but that's about it. But I will not be back to school until next Tuesday. I hope you guys are doing well, and I really wish we had more time before I had to leave so we could go through some more stuff. But I know that you can do this, and you can probably do it real well. As I usually say, you guys can do tons of stuff. You just need to set your mind to it. You just need to know that you can do it. Most of my job is just encouraging you guys to do this work well. All right, so let's get into it. We're going to be talking about how to make perpendicular lines. And in particular, we want to make perpendicular lines when those lines aren't straight. If I draw you a vertical line right here, nice vertical line. Well, a perpendicular line is pretty simple. It's a horizontal one going left to right. Everybody can really get that idea down pretty easily. But what if I have a line like this? How can I get a perpendicular line to that? And how can I know that it's perpendicular? Well, if you think about the vertical lines, you'll think, well, maybe it just goes like this. But you may not be sure. See, the important thing about perpendicular lines is that their angles, the angles that they meet, are 90 degrees. So hold on just a sec. Let me draw that again. So this angle and this angle are 90 degrees right there. And so if we rotate it like so, that 90 degrees will stay there. See that? So whenever we are trying to make a perpendicular line, we want to keep that 90 degrees. And if you remember from our transformations that we've done in the past, the main transformation that we use is, or one of the main transformations is a rotation. And a rotation tells us to rotate things 90 degrees. We can rotate 90 degrees with the rotation. So let's go ahead and do that. So let's go ahead and make sure we understand this basic idea that horizontal and vertical lines are perpendicular. So if you have a horizontal line and a vertical line, you know that they are perpendicular. A horizontal line here, vertical line here, perpendicular. Horizontal line here, vertical line here, perpendicular. They're always going to be perpendicular. So how can we do that and apply it to other types of lines? Well, it's not too difficult. I'm going to go through this first experiment with you, and then I want you guys to go through the remaining experiments yourselves. So, let's go ahead and follow through with these experiments. I'm going to go ahead and read through this part. It says, consider the points A, 2, 3, and B, 4, 7. A, 2, 3 is right there. Notice it's the coordinates 2, 3, and then the coordinates of B are 4, 7. 4 to the right, 7 up. Remember, our x-coordinate's first, y-coordinate is second. X and y. I know it's been a while since that, so we might have forgotten or gotten them mixed up. It's a pretty easy thing to do, so it's always good to go back to remember that. All right, so we've got those 2 points. The first question it asks is, what is the slope of this line segment? Well, if we want to know the slope, we got to know the rise and the run. So, how much does this rise and how much does it run? And you can probably see it right here. Oh, it rises 4 and it runs 2, or it runs 2 and rises 4. Well, that's pretty good. Anytime we want to figure out the slope, a great idea is to draw a slope triangle. It's always the best idea. And notice this slope triangle has a run of 2 and a rise of 4. 1, 2, 3, 4. So, our triangle from A to B has a slope, or M, that's equal to 2 over 4. Well, that's pretty nice to know. I also can see one other thing about this 2/4, and this is something that you can do. You don't have to do, but I do recommend that you start trying to do it, even if you don't do it well. Just try. 2 over 4 can be simplified. Okay? 2 over 4 can be simplified to 1 over 2. Or we can divide the top by 2 and the bottom by 2 to get 1 over 2, or 1/2. So the slope of this line is 1/2. Wait a second. I made a mistake. See, like I say, we all make mistakes. The important thing is we don't stop at our mistakes. We just keep going. And my mistake is a pretty simple one. This is the run and this is the rise. Our rise is 4 and our run is 2. If I look here, I actually put them on backwards. It should be rise over run. So I need to put the 4 on top and the 2 on bottom. 4 over 2. Okay? And so that changes our slope to be 2 over 1. Notice how it's very similar, just a little bit different. All right. So we got the slope of AB. That's very useful. Now it says locate the third point C on the coordinate grid so that the points A, B, and C make a right triangle. Well, we already did that with our slope triangle here. So point C is going to be right at this point right here. That's our C. Okay? So now we've plotted point C and we have this really cool right triangle. And if you notice, something special about the right triangle is we have a horizontal and a vertical line. So if I want to work with a perpendicular line to that, I know my vertical line and my horizontal line are going to have to change because horizontal and vertical lines are perpendicular. So how do we know it forms a right angle? Well, we got a horizontal and a vertical line. Those form a right angle. We have a horizontal and vertical line. Our vertical, we have horizontal and vertical lines that form a right angle. See, and I just made the symbol for a right angle. All right, now rotate this triangle 90 degrees about the vertex point 2, 3. So this is where we're going to get out our patty paper, which you should have gotten from the center of the room. You're going to put the center of your pencil at point A. That's the coordinates 2, 3. 1, 2, 1, 2, 3. Okay, put the center of your pencil at that point. Trace the triangle on your patty paper. And we're going to rotate it. I do it a little bit differently on my iPad, so just kind of trace it on your own. And I selected that. So I'm going to highlight it here, and I'm going to duplicate this right there. So it's in the same place. Oh, it's in the same place, and that's exactly what I wanted. Now I need to rotate it 90 degrees. Now 90 degrees is really nice with our horizontal and vertical lines, because our horizontal and vertical lines will actually just switch places. When you rotate a horizontal line 90 degrees, it becomes vertical. When you rotate a vertical line 90 degrees, it becomes horizontal. So it's easy to tell when we rotated it enough. It just goes like this and goes down like that. I made mine a little too big. There we go. And that's how mine ends up. I rotated 90 degrees. Okay? Now, if you traced this on patty paper, you wouldn't have to make this line. Since I didn't, and I used my iPad, I do have to make that line. And this is point A, this is point B. And see, wait a second. This is point B, this is point B. This is point C, this is point C. We can't have multiple point B's and point C's. So of course, if you've forgotten what to do, we add an image symbol to the end of those letters. C prime and B prime. This is our rotation, and this blue line is perpendicular to our black line. A, B is perpendicular, that upside down T is a perpendicular symbol to A, B prime. Okay? So those two lines are perpendicular. That's what we wanted to do. We wanted to make perpendicular lines. Now let's take a look at this triangle. First, to answer the next question, it says, Explain how you know that you've rotated the triangle 90 degrees. We go ahead and change colors on that. The way that we know is because the horizontal line became vertical and the vertical line became horizontal. In other words, I'm going to write this in regular writing. Horizontal line became vertical. Okay. The vertical became horizontal. All right. And so let me just go over that again. Our horizontal line right oh, that was not what I wanted. Our horizontal line right here became vertical. And our vertical line right here became horizontal. That's what I mean. All right. So now question number 5 says, compare the slope of the hypotenuse of this rotated triangle, that's the new one, with the pre-image, that's the first one. What did you notice? Well, if we take a look up here, let's take a look at the slope of that new line. And I'm going to use, not red, let's use orange for the slope. The slope of our perpendicular line is equal to rise over run. I'm going to write that down so I don't forget it. If you remember last time I made a mistake. Rise over run. Okay, so what's the rise? Well, if I look here, we went down 2. Our rise isn't up 2, it's down this time. So our rise is down 2. And our run is over 4. We went this direction by 4. If we would have gone this direction, we would say it's negative. But we went this direction, so it's positive 4. So negative 2 over 4. That looks pretty similar to what we started with. If you take a look at the red one, that's 4 over 2. This one is negative 2 over 4, so they're very similar. And let's go ahead and simplify that down. I'm going to divide the top and the bottom by 2. And this time I didn't make a mistake, so that's kind of nice. So it'll be negative 1 over 2. And if you take a look at these two slopes, I want you to compare our original slope to the new slope. Okay? So our new slope right here to our original slope. Think about how those are different. And we're going to write down what the slopes are. The slope of our original line, which was pink, m was equal to 2 over 1. But the slope of our perpendicular line is equal to negative 1 over 2. Now we might have noticed that those slopes are flipped and they're negatives. Notice how there's a negative here. There's not a negative there. This one is 1/2. This is 2 over 1. So they're flipped. The 2's on top, now it's on bottom. The 1's on bottom, now it's on top. If you remember what I talked about in the first semester a lot, mathematics is really the study of patterns. And this is a pattern that we can notice here. Okay? The slopes, and I'm going to write this down here, the slopes are flipped. We have an advanced mathematical word for flipped fractions. We call them reciprocals. Okay, there's flipped or they're reciprocals, and they are opposite signs. Okay, so the slopes are flipped or reciprocals, and they are opposite signs. Now, you have a few more experiments to do. I want you to go ahead and do experiment 2 following the same steps. Graph the slope triangle, rotate it, graph the new triangle once it's rotated, then look and compare the slopes between the original line and the new line. Okay? What's the difference between those slopes? Okay? And the idea here is at the end, first for you to get some practice with rotations, and the second part is for you to notice a pattern with these rotations to help us to see about the slopes of perpendicular lines. So I hope you begin to understand that rule. Go through these experiments. I guess there are 4 altogether, so you got 3 more you can do. You'll work on these today and tomorrow, and then you will do the homework. Specifically, actually, I don't think you're ready for writing the equations of the homework or anything yet. I think what I gave you, these 4 experiments, will be enough for you to do on Thursday, and you'll be doing the homework on Friday. I'll give you another video to help you out with that. I'm sorry I couldn't be there, guys, and I hope to be back on Tuesday if all goes well. If not, it might be a little bit longer. Have a great day, and I'll talk to you later.